Today, I will show you the use and design of six-way valves, which makes it possible to cover both heating and cooling with only one consumer. In this building, underfloor convectors are used for both heating and cooling. These are therefore supplied alternately by both systems. The supply and return pipes are laid in the screed and are supplied by the heating unit on the ground floor, in this case a gas condensing boiler, and by a cooling unit on the roof. To enable the connection of the underfloor convectors to both systems via only one supply or return pipe, we need an appropriate control system. Since this is becoming more and more common, we also support six-way valves that takes over this control and perform the desired switchover. You can use six-way valves with or without a control group. The integrated valves are then taken into account in the heating and cooling pipe network calculation to determine the optimum dimension for the two distribution networks, and then subsequently to calculate the correct settings of these six-way valves for the hydraulic balancing. Let's start with the calculation of the heating pipe network. The calculation runs through, and we now take a look at the results for one of the underfloor convectors. This is easily done by using the search function. So I select one of the underfloor convectors in the model, and then I get this one displayed in the calculation dialog. As you can see, the convector has been calculated with all the required values such as the pressure loss. Now we do the same for the cooling pipe network. So we change to the cooling discipline and start the calculation in the Analyze tab. This runs through as well without any problems, and we can display the results here in a printout. In this case, I will just put all results for the heat loss into the printout and create an additional material list. Again, we get the determined values for the convectors and find all components, including the used six-way valves, in the material list. Finally, let's take a look at the stored data in the six-way valve in the model. First, I display the technical data and get all values for this particular valve. So I see the mass flow rate, the design mass flow rate, the nominal design diameter, and also the pressure loss. All the calculated values can then of course be found as shared parameters on the component. These are displayed in the Revit properties. Since the pipes from the six-way valve to the respective convector are now part of both the heating and the cooling system, they are assigned to the new heating-cooling system type. Thus, combined systems in which the same components have two different functions can be calculated easier with linear workflow instead of workaround.